Hello, and welcome to Skynet Today's Last Week in AI podcast, where you can hear AI researchers chat about what's going on with AI. As usual, in this episode, we'll provide summaries and discussion of last week's most interesting AI news. You can also check out our Last Week in AI newsletter at lastweekin.ai for articles we did not cover in this episode. I'm one of your hosts, Dr. Sharon Zhou.
And I am your other host, Andrei Kurenkov, and this week we'll be discussing our usual mix of application and business, where we'll talk about GitHub using machine learning for software vulnerabilities and AI-developed drugs. We'll talk about some research on using AI for DNA sequencing and how AI compute has been growing recently. We'll talk about some society and ethics story about China regulating AI and AI being used in Russia's army. And we'll finish with some fun stories about vacation photos of zebras and using AI for choosing your clothes.
And let's dive straight in. Our first article in Applications in Business is how GitHub uses machine learning to extend vulnerability code scanning. And so GitHub is hoping to detect vulnerability patterns in code using some machine learning. And so up until now, they've been using human experts to help detect situations in which, user data might end up in a dangerous place. And they have encapsulated all of this knowledge in these CodeQL queries. And now they are trying to get not only, use this data of security experts curating and figuring out and analyzing these existing vulnerability patterns. They are now trying to use machine learning to identify some of these vulnerability patterns, both now and in the future, to help with finding these vulnerabilities, which are quite critical given how much code that GitHub hosts. And what's interesting is that they ran their ML-based code scanning on a number of the most common vulnerabilities in both JavaScript and TypeScript, which are quite common. And this includes cross-site scripting, path injection, NoSQL injection, and SQL injection, a couple of which you may have heard about. And based on the current data, GitHub actually said that while the metrics vary by query, they have a recall of approximately 80% and a precision of approximately 60%. So quite decent, making progress towards this front. And it seems like a really important direction to be pushing on and to have automated methods for identifying these vulnerabilities in addition to having human experts.
Yeah, exactly. This automatic scanning for vulnerabilities is quite interesting to me. This approach of turning rule-based techniques that just scan and apply a sort of template to then use that to train a machine learning model that can hopefully generalize and catch things that aren't quite as hard-coded. This I think was quite interesting, and it does sort of follow in the trend of all of these papers working on AI for writing programs or for completing programs, where coding and programs is something a little different than traditional text in NLP, because it needs to be very precise, right? It needs to be grammatically correct, or else it doesn't run, which is more challenging for neural nets than something like translating languages between different, or translating text between different languages, potentially, because there is less kind of a strict grammar to follow. So it's interesting to see all this research going on, and obviously software runs the world these days. So the more machine learning we'll see dealing with software, the more AI will just be everywhere, I guess.
And specifically what they did that was interesting. So the machine learning method wasn't actually, that novel, but it was actually in the way they did labeling that was kind of interesting, which is that they used their CodeQL rules, which are these, vulnerability patterns, but they're a set of rules that they can apply to tens of millions of code snippets. And they can do this with, relatively little effort and with these rules, they can then, provide these as labels to the machine learning algorithm that hopefully then can generalize beyond those rules, instead of having experts be labeling these millions of snippets.
Yeah, which is quite interesting as well, because I can totally imagine some of these things like vulnerabilities is a total cat and mouse game, right? Where there's new ones all the time. So you might have this backlog of previous sort of steps and additions and so on. And with this kind of approach, you can potentially get ahead in this cat and mouse game, right? And, the cat can, I guess, go faster or something.
That being said, I'm curious to see how well this generalizes too, given the fact that it is trained on these rules, and whether it can help participate in that cat mouse game. Because right now it's also being evaluated on simple things. That code that their original rules based system is able to detect as well, CodeQL.
That's true. Yeah, and it also would be interesting if they do go for something more interesting. As you said, this is fairly straightforward, but there are ideas you could see where it's more of a hybrid. You still have rules, but it's augmented by an AI model, something like that. That would also be pretty cool. So I'm sure there are papers on this that we just don't know about. There's a whole field of research with interesting ideas, but it's cool to see this actually being deployed by GitHub, or at least being researched for deployment. And talking about deployment, we have our next story titled "First Wholly AI-Developed Drug Enters Phase 1 Trials." So there's been a lot of excitement about the potential of AI to be part of drug development, which is generally a very kind of long process. It takes a lot of experimentation and verification and testing to get a new drug for any given thing. And in doing this development, you need to go to this phase 1 trial, where it's the first time it's tested in humans at the dosage level required for therapeutic effect. So it's just for testing safety and not so much clinical effectiveness. And then before that, drugs go through preclinical trials and smaller doses and so on. And this is all after a drug has been developed, right? So this article is about how this company in Silico Medicine has a drug that is set to start a phase 1 clinical trial that was developed, so to speak, end-to-end by AI. So they worked on this drug that should help with idiopathic pulmonary fibrosis, which stiffens the lung tissues of older people and affects a lot of people, 5 million each year. And to keep it short, it's interesting because it was a 3-part AI-powered process that was drug. There was Pandaomics, where it was NLP to crawl massive data sets. There was Chemistry 42, a type of AI where they used a GAN to identify a molecule. And then there was another technique, the first step, where AI was used to monitor the effects in volunteers. So yeah, I haven't been following this too closely, but it seems like an exciting step. What do you think, Sharon?
I think this is, very, very cool that we are now starting to see these types of drugs actually being developed by AI completely and being now put out there. I'm curious to see how this progresses beyond these initial phases, and whether this will become more and more the norm of how we push these drugs out.
Yeah, exactly. It's a big space. There's a lot of people working on it, and I think right now I certainly don't have the required background knowledge to understand how big a deal this is. But certainly, this is a milestone, and it'll be interesting to see what we get next.
Seems like a really cool application of a GAN. It's also what I'm going to say. I am very impressed they were able to use a GAN to do this.
To identify a molecule for an effective drug against this disease, not just to draw a human face.
Yes, I agree. Yes, because in my head, I think of GANs as doing that, but this is fantastic. Mm-hmm. And on to our research and advancement section. Our first article is Stanford University uses AI computing to cut DNA sequencing down to 5 hours. All right, this is a new Guinness World Record, and it is for the fastest DNA sequencing technique, and it's using AI to compute it. And this was published in NEJM, the New England Journal of Medicine, which is one of the top medical journals out there. And this involved speeding up every single step of genome sequencing. The entire workflow, and much of it was supported by AI using to generate more than 100 gigabases of data per hour, and NVIDIA GPUs on GCP, on Google Cloud, to speed up the base calling and variant calling processes. So this team was, from Stanford, and they actually had 12 patients enrolled, and they had their genome sequenced. And of the total, 5 of those patients received a really fast return on their genetic diagnosis. One of them actually had it in 5 hours and 2 minutes, which is breaking the record by quite a bit. The previous record was 14 hours. And this team thinks they can, have that number again. And just to give a little more context, there's another article that goes into a bit more detail titled "The Fastest DNA Sequencing Technique Helps Undiagnosed Patients Find Answers in Mere Hours" from Science Daily. And this article goes a bit more into the utility of genome sequencing, and specifically that if this is really, really fast, and you can get a answer, before the end of a hospital ward round, you could actually understand a lot more about the patient, know what their, genetic variants or mutations might be, and whether they have anything that is rare that needs to be handled in a specific way. And so this is really useful down the line once this becomes very fast and very cheap. And you can imagine this being used across hospitals everywhere.
Definitely, yeah. And, DNA sequencing is one of these things that has been improving rapidly for decades, going from, it being incredibly expensive to getting a single sequence of human genome or something to that effect, to now it being possible to sequence a given person's genome relatively quickly. And I've seen it pop up in various contexts where now you can use this, especially, in children and babies, but also in other contexts. It's very cool to see this sort of ease of use going faster, and hopefully just making it more easy to do rapidly. There's actually an article not an article, but a little explanation of this in the New England Journal of Medicine, where they call this ultra rapid nanopore genome sequencing in a critical care setting, which was kind of a fun read. I did not understand any of it, but they do go through a lot of kind of the steps they took to speed things up incrementally, and kind of all the little cuts they managed to make. I think as we often talk about, it's cool to be aware of all the less talked about applications of AI. We all know self-driving cars, we know computer vision, whatever, but I think a lot of these more esoteric use cases or use cases we haven't heard of, like looking for software vulnerabilities or like speeding up AI or speeding up DNA sequencing, that's what's really exciting to me as we do this podcast. That's what I really look forward to learning about.
Yeah, agreed. Likewise.
And moving on, we have our next story titled AI Machines Have Beaten Moore's Law Over the Last Decade, Say Computer Scientists, from Discover Magazine. This is a slightly clickbaity title, but fairly accurate. So it's all about this new paper titled Compute Trends Across 3 Eras of Machine Learning. And interestingly, it's by 6 authors from all over the place. There's the lead author is University of Aberdeen. There's the Center for Governance AI, University of St. Andrews, the University of Tübingen, University of Madrid, and MIT. So real, international collaboration, which was neat to see. And essentially, it follows up on some prior work. There's been several papers that have tried to establish the trend of how much computational power was used in AI research over time. So if you can measure, how many compute cycles of a CPU or GPU was required to train a given model to get the kind of main result of a paper, people have tried to basically get these sorts of numbers for a bunch of papers and then see if you can actually then fit an equation to see the trend. So is it like, what's the slope of a line essentially? How rapidly is the compute being used increasing? And in this paper, they make the case that like some other papers, there's been a shift between AI pre-deep learning and in deep learning, where pre-deep learning prior to about 2010, it was a fairly consistent improvement that matched Moore's law, which is just saying that compute power was increasing approximately doubling every 2 years, which is also what Moore's law is about, is the density of transistors doubling roughly every 2 years. And then post 2010, when we got to deep learning, the trend has accelerated to the compute power doubling every 5 or 6 months, in fact. So it's been growing much faster. And that's in large part due to using GPUs and using other hardware besides CPUs. And lastly, this paper is a bit novel from prior work in that it also now talks about large-scale era models like GPT-3, which are even breaking the trend of deep learning and are kind of on a different trajectory, which was interesting. So it's a nice breakdown. They have 120 papers to analyze, so a pretty nice data set. Does this, I guess, ring true to you, Sharon, as far as this breakdown?
To some extent, I would caveat to say that a lot of, this new trend is also a function of how humans organize and how we've been organizing ourselves, for example, into these larger research institutions like DeepMind and OpenAI, creating much larger models because of the concentration of resources, both human capital and, compute. So I think it's in part due to that as well. And I don't want to say it's only because of the way we've been improving machine learning and training compute and everything. It's also a huge, huge function of how we're organizing ourselves in getting to that next leap.
Yeah, exactly. And that also actually is somewhat covered in the paper, where they actually explicitly say that this large scale era starting around 2016, where it's these mega large models that don't match the trend of deep learning, that it started with AlphaGo from DeepMind was maybe the first big example. And then it has been basically in industry labs that have released these large-scale models, which are accelerating about as fast, or actually their computing is accelerating slower than general deep learning, but they are using kind of at the starting point orders of magnitude more compute than the general trend. So it's definitely kind of showing the bifurcation of resources between general academia and research and industry scale research.
In industry, it's very apparent. They're seeing, limits to their compute with the hardware they're also buying. So they are also finding new ways of developing their own hardware to make that both much more cost effective for them if you do it internally, but also generally more cost effective and more efficient when training something or doing inference.
It's also kind of interesting as this hardware gets developed, right? It sort of is also enabling not just these hyper large models, but everything else also to rise along. Any new GPU, any TPU, all these things, any optimization will help. And because this large scale era, tech models are doubling every 10 months, whereas the regular sort of all of deep learning is doubling every 5 to 6 months, they're sort of converging in the graph as of right now. So deep learning is heading towards the large scale era where everything is gigantic. So it'll be interesting to see if in a few years, everything is hundreds of billions of parameters, or most models are. It's certainly feasible, but it's kind of hard to imagine right now.
And on to our next section on society and ethics. Our first article is China is about to regulate AI and the world is watching. And so last week on March 1st, China actually outlawed a kind of algorithmic discrimination, which is their first step in regulating artificial intelligence. And under these rules, companies will actually be prohibited from using personal information to do price differentiation on any kind of product or service. And this is a sweeping rule. This covers, algorithms that set prices. This covers search results. This covers recommendations of videos. This covers filtering of content. And they will impose this on, ride-hailing services, e-commerce, streaming, social media, just all over on the most popular, most valuable tech companies. And this is really interesting as we watch China do this, because China can just make a regulation change overnight and apply it to everything. I think based on how we perceive China here in the West, it might seem as a surprise that they're the first to be regulating AI, but it actually is in line with the Chinese public, and the Chinese public is quite supportive of these measures to curb the power of big tech platforms, which is very similar to how I think the sentiment is now in the West as well. So that is actually quite consistent. The article does mention that, some of these new regulations will be hard to enforce and it could, be very challenging. But China has also said that any companies that violate the rules could face fines. They could be barred from enrolling new users. They could have their business licenses pulled. They could have their sites or apps shut down. So it's quite a big change that would essentially shut down the business or growth of the business if they are found violating any of these things.
Yeah. This is kind of seems like a big deal, and I'm pretty sure most people out here in the West are not aware about kind of the landscape of regulation of AI in China. Last year, we talked about how China had a sweeping set of regulations about facial recognition and how the government is now regulating the use of facial recognition by private companies, and they must basically be audited and make sure that their use case is warranted. And now they are going beyond that to just looking at other negative impacts of algorithms, like just promoting addictive content, which is obviously a huge deal because most of social media is promoting addictive content. Most like TikTok is, the quintessential algorithm-backed addictive content. So yeah, I think it is very interesting, and it is very worthwhile for people in the West to maybe be aware of this as kind of a status of AI development in China, and just be aware of that. These sorts of very severe actions or regulation that I think can be argued to be very positive are happening there.
Right. We can't just paint it as black and white, of course. A similar type regulation is that ByteDance, which owns TikTok, but also Douyin, the short video app in China, actually started showing 5-second videos that tell users to log off after they've been watching for a long time. And I thought that was just a really interesting way to curb addiction to this very addictive feed that the algorithm is giving you, that it knows what you'll like next and keep you going. So it's adding that in, and that is in part due to other regulation that China did have around these algorithms. So there's a lot being done in these big tech companies, and it's something that I think we should very much be watching here and seeing what works and what doesn't, and perhaps using some similar measures, perhaps implemented in different ways, but similar measures on some of the companies here, depending on whether we see similar, negative societal impacts that China is seeing.
Yeah, definitely. This thing you mentioned also, the idea that popular apps, like the majority of them, have a way for users to opt out of personalized recommendations because of this law is a huge deal. And is just starkly, in the US, that seems an impossibility, right? That's just what is the default. So definitely worth being aware of, and to, think of whether something similar could be accomplished out here for these negative impacts. And on to our next story about society and ethics. Pretty sad topic, but one that does warrant discussion. We're going to touch on the ongoing war between Russia and Ukraine. And in particular, there's an article titled Russia's AI Army, Drones, AI-Guided Missiles, and Autonomous Tanks, that goes into how Russia's army, obviously it's much bigger. They have a very high investment in it. It's the third largest army in the world. And technologically, of course, it has many resources. And part of that are these weapons that are AI enabled, AI powered. They're not necessarily fully autonomous, but they would not be possible without AI. So for instance, like most militarized rich nations, Russia has fleets of drones. So it has drones here. They have specific examples like the KUB-BLA drone that can destroy remote ground targets, deliver payloads, and you can set where it should go based on remote control or based on just setting in an image where it should go. And then the drone's AI guidance system can get it there. And now it has even newer drones that have been developed more recently. On top of that, they have also a variety of other semi-autonomous or autonomous weapons. So they have unmanned ground vehicles that can be used from bomb disposal to anti-aircraft and actually fighting against people. And they have these AI guided missiles, right, that can change targets mid-flight, in fact, which is pretty stark. So it's an interesting article to read, just to be aware of, this whole vision of AI in the military and robots in the military that we have from popular media like Terminator. That's not at all here, but in many ways, AI is making its way into military technology already. And personally, I suspect that having all these unmanned technologies, all of these drones, all of these missiles just makes it possible to be even more destructive and to just, without having as many people on the ground, just send in bombs and, target cities, as Russia has been doing with a lot of bombarding. So it was good to read about this. And I think possibly one of the positive outcomes of the situation could be more discussion as to how to regulate autonomous AI-powered technology such as this. But obviously, at the moment, that's not the focus.
I also found it interesting from the article that Russia is one of the biggest spenders on defense in the world, with about $62 billion spent in just 2020, probably gearing up for what they're doing now. And they're only behind, U.S. and China here. But specifically, they also did mention, or President Putin did mention in 2017 that, quote, whoever becomes a leader in AI will become the ruler of the world. And so he definitely has been thinking about AI and of course, relative to in relation to defense spending. Of course, all three of these large countries have been thinking about both of these things. So it's not a huge surprise. It is interesting to see these deployed now and being used for something so real and pertinent to the world right now.
Yeah, and there's been organizations such as the Campaign to Stop Kill Robots, I think we discussed it before on this podcast, that have argued for regulations and sort of laws, international standards for these sort of technologies. In fact, I recall last year we talked about how there was a sort of conference in the UN where a lot of countries wanted to do this. And the US, as well as some other countries like India and Russia, basically backed away and said no to regulating anything that has these sorts of autonomous capabilities. So, I think this is an issue that maybe does deserve more attention. We talk a lot about deepfakes, we talk a lot about biases, but we don't talk a lot about this topic, maybe because it's more hidden. But I do think it's definitely happening and deserves attention.
Well, I think we were, at least even now in the US, we are not directly super affected in our day-to-day by this, aside from reading about the news. And so it doesn't feel as at home as the other stuff, which does feel like we are affected as consumers day-to-day by certain aspects of, police using facial recognition, for example. So here, I think it largely is about, maybe it's about that, where the news doesn't hit us as much on this angle. But I do think it's a really important aspect to be talking about. And the AI community and general tech community has had a very interesting relationship with defense and traditionally has been pretty much shying away from it. And I think now I've heard more and more voices actually say the contrary and start to say, maybe we should be developing this if we want to be able to, combat Russia, for example, if they were to come. And so it's interesting to hear how that rhetoric has been potentially changing, at least from people I'm surrounded by. And it really depends on what's going on in the world and how much threat is perceived.
Yeah. That's an interesting point. In general, that relationship is interesting. On the one hand, most AI researchers and tech people in general don't like the idea of working for military or military technology. On the other hand, DARPA, the advanced research arm of the US military, has funded a ton of AI research over multiple decades. Really, a lot of robotics research is just fueled by the US military. Part of why Jeffrey Hinton, one of the most important figures in AI today, wanted to go to Canada, is that he did not want to be funded by the military. Even if you're not doing anything directly related to the military, in many cases, the funding was coming from there. So it's an interesting relationship, and it's becoming more and more relevant, it seems. And as you said, maybe for people who are doing AI research and people in tech, it's a time to sort of be more aware of this relationship.
And on to our fun and neat section, much lighter. The first is how vacation photos of zebras and whales can help conservation. So scientists are using AI to analyze photos of zebras, of sharks, and of various animals to identify, individual animals as well as track them and offer new insights into their, movements and their overall population trends. And they use some kind of AI to search through publicly shared social media posts now for relevant species. And that might mean a lot of people's vacation photos. And that could mean, sharks that they saw in the Caribbean. And that will then downstream now be used for science and conservation, which is pretty cool. And they're just, they're doing population counts, they're checking birth and death dynamics, species range, social interactions and interactions with other species, including with humans. And this is so interesting to be basically, I'm imagining, leveraging Instagram for this kind of analysis.
Yeah, this is super fun to just, imagine being doable, that just people posting their vacation photos of cool looking animals. If you collect that data over a lot of different photos, you actually can use it to gather useful information and help with these efforts. It's a very fun idea. And it does kind of speak to, GPT-3. A lot of modern AI is just scraping what we put up on the internet and learning all sorts of things from it. And this is an example where that's the case, but it's more directed than just learning anything. So it's kind of fun to think about whether there are any other potential use cases like this where, given a particular context, you can just collect a certain type of data and then use it for a useful end result. That's not just like fun vacation photos. Fun story.
And there's a new institute even, the Image Omics Institute. People talk about all sorts of omics, like genomics, but this is the Image Omics Institute just to do this. And the NSF gave Ohio State to create this about $15 million back in September. And just to give you a sense of some of the questions that they're probing at, given the photos, they actually get quite complex. So, for example, is the pattern of stripes on a zebra similar in a meaningful way to its mother's pattern? And if so, can that give information about their genetic similarities? It's so interesting. That must be from photos of, the mother and the baby. And then also, how do the skulls of bat species vary with environmental conditions, and what evolutionary pattern, what evolutionary adaptation drives that change? And so, different environmental conditions, they will have to, detect what the environmental condition is and that there's a bat there and a type of species of bat in in doing that analysis. So this is very interesting and quite the feat in crowdsourcing.
Yeah, exactly. And looking at this new Imageomics Institute, I guess this article might have been in part because a few weeks ago, they released a new article in Nature Communications titled "Perspectives in Machine Learning for Wildlife Conservation," in which they outlined this whole new direction, essentially, like you said, that you can do a lot of these things from all this image data out in the, so to speak, wild, in the wild of the internet, and I guess also in the wild of wherever photos are being taken. So maybe not, this is, I would say, maybe cool as on top of being fun and neat. Yeah. And moving on to our next story, that's pretty fun. We have Walmart's Choose My Model helps shoppers try on clothes virtually. So Walmart has launched Choose My Model, which is a virtual tool powered by computer vision and AI on the company's website that allows shoppers to pick a person who resembles their height, shape, and skin tone to show how clothes would fit, according to a recent press release. So at first I thought this would be like you try on clothes via computer vision. It just takes a photo of you and then projects the clothes onto you or something like that. But in fact, the idea here is they take photos of these clothes with many different models, human models, actual people wearing these clothes and being photographed, maybe 100, 200, just covering a large variety of different heights and shapes and skin tones. So instead of generating a sort of synthetic image by combining a photo of you and these clothes, now you have high quality images from many different types of models representing different ethnicities and shapes and so on. And AI here is really just used to kind of find the best fit that might be representative for you, which is actually, I think, is a nice approach. I think maybe it's a little obvious to just go to virtual try-on with AI, but I think it's also smart to start with real data and just sort of have AI make it easier to access the right photos as opposed to just creating new ones. What do you think, Sharon?
I mean, I think this makes sense. I think people have been talking about such a tool for quite some time. And to see this actually deployed at Walmart is pretty exciting to see how much people actually like it and use it. I haven't used it yet. I don't really shop there. Actually, I've been trying to not shop that much at all. But yeah, I think this makes a lot of sense, and to see how people fit into these clothes, because I will say that it is challenging to figure out what you'll actually fit into, especially online. So to help solve that problem would be amazing. And it's not just like the fit of it, and also just like the material, how it flows on your body as you move. So I think the next step is getting a short video of the model moving as well.
Good point. And then we have one more story I just added for fun that we weren't planning on originally. I just tacked on this one story called Baidu plans 100-city Robotaxi rollout by 2030. So they plan to introduce an autonomous taxi service to 65 cities by 2025, and then another 35, 60 by 2030. And this is fun because I think both you and I, Sharon, are not big fans of driving. I just got my driver's license last year, and I don't know your status, but I look forward to a robotaxi future where we don't need to drive. Yeah, I think we need to just get there. It's so much nicer than owning a car and having to deal with all this stuff. And I just want a robot taxi to drive me around. Let me just use my phone to call one and get wherever I need. That's my dream.
I agree. This is the dream. And I can imagine China rolling this out before us.
Exactly. Yeah. If, as we've
65
seen,
cities. Yeah. 65 cities is quite a bit. Yeah.
Yeah. It's maybe the 65 cities are the less big ones.
I imagine so.
Yeah. Because something like Shanghai would be, crazy.
Yeah. Beijing is going to be like last. And Shanghai, they're going to be last. Or maybe they're not even on this list. Yeah.
Yeah, like in the US, we are seeing some progress, very, very gradual progress. Waymo is now starting to work in SF as a beta, and then Cruise is also working in San Francisco to some extent. And I guess Tesla is sort of everywhere in its beta full self-driving. So
right. So
hopefully by 2030, we'll have some robotaxis. I don't know.
I'm keeping expectations low just so I can be pleasantly surprised when it happens.
Yes, let's do that.
And with that, thank you so much for listening to us on this week's episode of Skynet Today's Last Week in AI podcast. Again, you can find the articles we discussed here today and subscribe to our weekly newsletter with similar ones at lastweekin.ai. And make sure you leave us a review and tune in next week.
Yeah, leave us. Are you a friend of mine listening? Because if you're a friend of mine and you haven't left a review, come on.
Are you a friend of mine?
Calling you out.
You're going to lose a lot of friends, or we're going to get a lot of reviews. I do not know. I
don't think my friends listen to us. But
I don't. If you're listening, do you want to become our friend? Because
I'll be your friend. Leave a review that's nice, and I'll hang out with you. Okay, it's a deal.
That's right.
Anyway, yeah, be sure to tune in next week.